Hi, my name is Kevin Jones, and in this walkthrough, we'll see how to install the rock-solid knowledge FIDO component for use in Identity Server. So before I start writing code, I want to show you what we're aiming at. So here, I have a copy of Identity Server running, and I also have an ASP.NET MVC application that's using Identity Server to provide authentication. At the moment here, we're unauthenticated. What I'd like to do is to provide two-factor authentication using a FIDO device. So to do that here, if I click on the privacy link, this is going to ask me to log in. And if I log in, it takes me to the privacy page. So we have single-factor authentication. What I can now do here is register a device. I give this device a name. In my case, I'm using a UB key, so I just call it UB. It asks me to touch the key, and that device is now registered. Now, if I log out and then click on privacy again, this time it requires two-factor authentication as it knows I have a device registered. So again, I touch the key and now I'm authenticated. And if I go to the home page and the privacy page, it knows I'm authenticated and I don't need to re-authenticate. And what we'll see in this walkthrough is how to do this. So we'll see how to provide device registration and we'll see how to provide login using that device. So as a starting place for this, I have two applications set up here. I have an instance of Identity Server, and I've built this using the standard templates. And the only thing I've changed here is that for the MVC client, I've changed the URIs, so they're using HTTPS, and I've turned off consent requirement. And I've only turned off the consent requirement just to make the UI flow slightly easier for the demo. I've also changed this, so it's running on port 5000 as HTTPS. Within my client application for this, we've added authentication and we've added OpenID Connect. And OpenID Connect is using HTTPS localhost 5000 as its authority. That's Identity Server, and it's adding the appropriate scopes for this particular client configuration. And also within here, if I look inside launch settings, we're running on port 5003 for HTTPS. So if I run both of these, so I run IDS first and also run the client, we'll see IDS is running on localhost 5000 and it's running as HTTPS. And the client is running on localhost 5003 and it's also running as HTTPS. Within the client, I've marked the privacy endpoint as authorized. So if I click on this, it asks me to authenticate and I'm now authenticated. But notice at the moment here, there's no mechanism to register a key and there's no mechanism to use two-factor authentication. And that's what we'll add now. So to make use of FIDO, we're going to install the FIDO component from Rock Solid Knowledge. So to do that, I need to add a reference to this component inside my Identity Server project. So from here, I can go manage NuGet packages. But I'm looking for a package called rsk.asp.netcore.fido. Notice there's an entity framework package here as well, and we'll come back and talk about this later. For now, we'll use FIDO within an in-memory store. So I'm going to add this package to Identity Server, and then once that's done, I need to register the FIDO component. And we do that inside configure services. So at the end of the code here, I can call services.addFIDO. And this takes an options, and into this options, I'm going to specify two values. I specify the name of the licensee and the license key. And we'll see how we get these in a moment. I'm also going to tell the component that I want to use the in-memory key store. So initially, while we use this, all data that the component needs is held in memory. When we restart the service, then that data will be lost and we'll need to re-register again. Later on in this walkthrough, we'll see how to use an entity framework key store here. So to get a copy of this license for this component, you can go to IdentityServer4.com. And from here, in the product section, FIDO2 for ASP.NET, you can download a demo version to try this, and you can also purchase the component here as well. So before we write the code to manage the registration, let's understand how registration will work. So a user who's been authenticated will walk up to the browser, then enter the user details, and part of the details in this case could be the name of the device they want to register. Once they've entered that name, we start the registration process at the server, we'll insert the user into the database and start what's known as device registration. This will send a challenge back to the browser. The browser then calls an API called navigator.credentials.create. And this calls something called the authenticator, and this interacts with the FIDO device. If that interaction is correct, we'll get back some public key credentials. We send those credentials back to the server, and the server will then finish the registration and insert those credentials into the database. This looks a little more complex than it is. So let's see how we do this in code. So most of the work for this will be done inside Identity Server and inside a file called account controller. But before we do that, I want to add a link into my client project. So inside the layout CS.HTML page, where we already have links to the home page and the privacy page and the logout page, I'll add another link here with the text register device that will go off to this account controller to an endpoint called start registration. And this is where we'll start the registration process for our FIDO device. So inside this account controller, I need to add this start registration endpoint. So we'll put that at the end here, and start registration will just return an action result. And the result we want to return here will be a page that contains a user interface that will allow the user to input the name of the FIDO device. Once that name's been entered, we can then start registration of that device with the FIDO component. Now, I only want to do this if the user is authenticated. So here, I'm going to say, if our user is authenticated, return this view, and if they're not, redirect back to the login page with the return URL that's this endpoint. My view will look something like this. It will be a form that allows the user to enter a device name. When the user clicks on the submit button, we'll come back to another endpoint called register. Now, I want the data in this view to be captured in a class called registration model. I'll put this in its own file, and this will have a single property called device name, making sure this is in the right namespace. So I also need to make sure that in my start registration page, I include a reference to the model I'm using here. And this is that registration model that we'll send back to the server. So this is the callback from the page, and this callback will take something of type registration model. So in the callback, I want to do two things. I need to register the device with the FIDO component. Now to do that, the component provides a service that I can use, and I can inject that service into this account controller. So in the controller's constructor, I can add a reference to an iFIDO authentication service, and we'll call this FIDO, and I'll assign that to a variable called _FIDO. And then down here inside registration, I want to call FIDO initiate registration. Initiate registration takes two parameters. It takes the name of the user that we're registering the device for, that we can get from the current identity, and the name of the device that we are registering. So UB in the example that we saw earlier. This is an async call, so I need to await on it. And to do that, I need to mark my method as async and have it return a task of iAction result. So here for the user ID, I'm using the user name, but be aware that normally for this, you'd use a value that cannot change. So maybe some GUID that's associated with that user that uniquely identifies that user. When I call initiate registration, this will return a challenge. I need to send that challenge back to the browser and then have the browser interact with the FIDO device. And we do that by returning a view, and into the view passing the challenge, but the challenge has to be base64 encoded. So there's an extension method provided by the FIDO component that lets me base64 encode this challenge. I want to return this view, and I can then generate the view page. So my view page is going to look something like this. I'm going to provide a method called register. It's a JavaScript function. And to this, I'm going to pass a number of different parameters. The challenge object we send out is of type base64 FIDO registration challenge. And out of this, I'm pulling something called the base64 challenge, something called the relying party ID, something called the base64 user handle. I'm also passing into this function the user ID and the URL to call back to once we finish interacting with the device. This function is in this JavaScript file, fido.js. Let's go and take a look at that. Okay, so this is the register function and the parameters it takes. So typically what we're doing here is turning string values, such as base64 challenge, into something called uint8 array values. So I have a helper method called getChallengeString, into which we pass this base64 challenge, and I turn that into a uint8 array. The relying party ID is the server address that this challenge is coming from. So in our case, that'll be localhost. The user handle is a value that identifies the user. And again, we turn that into a uint8 array. We create a user object based on that user handle and the user ID that's passed back in. Once we have all of that data, we then call navigator.credentials.create. This is the code that interacts with a FIDO device. If this succeeds, it returns with some credentials, and we're going to then send those credentials back to the server. And the place we send those credentials back to is this callback URL. So here, use jQuery, call it Ajax method. We send a query back to this callback URL, and we pass up a JSON version of these credentials. So this callback URL is specified as part of the call to the register function. And in our case, it's /account/complete registration. So I need to provide that URL. So in the account controller, I provide another endpoint called complete registration. Again, it's an async endpoint. And notice this takes this base64 FIDO registration response. That's the data that's being passed here as part of the Ajax call. Inside here, I take my FIDO component and I call it complete registration function. And then to this, I pass registration response converted into a FIDO response. This is an async call, so I await on it and it returns a result. If this result is an error, I return bad request. If it's successful, I return OK. And this return goes back to the Ajax call. So back inside the JavaScript file, if everything is successful, I set window location href back to my client application, HTTPS localhost 5003. If anything fails, I just dump an error into the browser's console window. So at this point, we should now have a device that's been registered and ready to use. So I need to do one more thing here. I'm using inline JavaScript. So if I look in register.cshtml, we have the script block. And at the moment, Identity Server's content security policy will stop this from running. So I'm going to cheat. So the way we set our CSP is in this security headers attribute file here. And currently it says default source is self. And I'm also going to add unsafe inline to this. Now I shouldn't be doing this. I should be explicitly setting out which source to run. But for the sake of brevity, and as this is only a demo, I'll just allow any inline code to run as well. So in the code provided with this walkthrough, I've actually done this correctly. So I'll show you in there how to add a nonce and how to regenerate that nonce on each request and add that newly generated nonce into the CSP. And you should do that rather than the code I've shown you here. Okay, so now that's in place, I can run Identity Server and I can run the client. So in the browser, we can see Identity Server is running. Within the client, I'll click on the privacy link and log in. And then I can now register my device. So I click on register device, give it a name. I'm using a UB key, so I'll just call it UB. Click on submit. It now asks me to interact with the authenticator. So I touch the key and the device is now registered, having been sent back to the home page. So that's the first part of the process, doing device registration. Now what we want to happen is, after I've logged out, if I click on the privacy link and I log in, I want two-factor authentication to kick in. So I want to have to use my UB key at this point. So let's see how we do that. So now that we've seen how to register the device, we need to see how to authenticate using that device. And that will be done as part of the login process. So login happens inside the account controller, inside this login method. And in here, we check to see if the model is valid as passed in. So this will be the user ID and password that came on the page. We then check that those credentials are valid against the user's store. And if they are, we then do the login process. The process that's here is the normal login process. So if there's no 2FA involved. So the first thing I'm going to do to make this slightly easier to understand is to extract this into its own method that I'll call doLogin. So inside the code now, we're saying if we have a valid form and the credentials are valid, then just log the user in as normal. So at the moment here, nothing has changed. We just do the standard login. But now I only want to do this standard login if I have no device. The first thing I need to do here is to check to see if this user has registered a device. And we can do that using another of the FIDO component services called the key store. So back in the constructor, I can inject another service called iFIDO key store and store that in a variable. And then back inside login, I can then interrogate that key store. So if the credentials are valid, I reach into the key store and ask it for any credentials for this user. Now remember, the user would have registered a device, and what this call does is retrieve any keys, any devices registered for this user. So if there are no devices, i.e. if this value is null or if the count is 0, then I proceed with the standard login. So I just return the current do login call. So this will show the login page and also show any consent forms needed by this user. So if I do have a device registered, I want to use that device as a second factor as part of the authentication. So here, I want to do a couple of things. I want to redirect off to a URL that will do the second phase of the authentication for me. And in this case, that's going to be a redirect to /account/FIDO login. But before that, I want to partially authenticate. And to do that, I'm going to call sign in async, but I'm going to sign in to the two-factor user ID scheme. And we'll see in a moment, as part of the second phase authentication, we'll check to see that we are signed into this scheme before we carry out the authentication. I'll also see that as part of this second phase, I'll need some information about this user. I'm going to need things like the user ID. I'll also need things like a redirect URL. So at the moment, if I look inside do login, we'll see that if this login succeeds, we redirect off to a URL that's been built by IdentityServer. So now we're managing the redirect ourselves, but if the second phase succeeds, we'll need to redirect it back to that URL as well. So as part of this sign-in async, I'm building a new claims principal, and inside there, I'm creating a new claims identity, and inside here, I'm going to put various claims for this user that I can use later on. And that's what this build claims method will do. So the build claims method looks like this. It creates a list of claim objects, finds the user from the user store, and then adds a set of claims based on this information. So it builds a remember me claim, which is basically has the user check this checkbox on the UI. And it then adds a redirect URL, a username, and a subject ID into this set of claims. So now back here, we redirect off to /account/FIDO login. But now we've signed in with this new scheme, and we've created a new principal with these claims inside that principal. Okay, so let's go and write this FIDO login endpoint. So we're still inside the account controller. So in here, I add an async method called FIDO login. And the first thing I want to do in here is to authenticate using this two-factor user ID scheme that I just signed in with inside the login method. If this authentication fails, I'm going to redirect off to some error page, as this means that we haven't gone through the base login process yet. So what if this authentication succeeds? So if it succeeds, I'm going to get the claims from the user. I can get that from the result of the authenticate call. I'm going to extract the user name claim. And then once I have that, I can initiate the second phase of the authentication. So FIDO initiate authentication. We'll call the FIDO component. It will use that component to discover information about the registered keys for this user. That's why we need the user name claim here. And that returns me back a challenge. Now, similar to registration, once I have that challenge, I need to send that data back to the browser so the browser can interact with the FIDO device. And we do that by returning a view, and that view is going to contain the data that we need. So for this, I need to build a model. So I'm going to create a class called FIDO IDS model, and this model will contain two properties. It's going to contain the result of the initiate authentication call. That's that challenge value, and that's of type base64 FIDO authentication challenge. It also needs to contain the return URL, and this is the URL that we put into the claims. This is the URL we need to return back to so Identity Server can complete this authentication. So back in the controller, we create a new model, we set up the challenge, and we need to set up the return URL. Now I get the return URL from the claims. So here, I call claims first or default on the redirect URL claim. And that returns me a redirect URL as a string. And I can now create the model and return the view based on this model. But we don't have a view yet. So let's go and generate that now. So similar to the registration view, the view looks like this. We include a JavaScript file. And then inside here, we call the complete login method that's in that JavaScript file. And to this complete login method, we're passing the challenge, the relying party ID. Again, we're passing down some keys. And notice at the end here, we're passing down this return URL. And that's the URL that we'll need to return to, assuming authentication completes successfully. The URL before that, the account FIDO complete logon, again is analogous to the complete registration URL we use when we're registering the device. So again, the process will be initiate the authentication in the server, send the view back to the browser, have the browser interact with the device. If that interaction succeeds, send that data back to the server on this account FIDO complete login URL. Okay, so what does this method look like? So again, this is similar to the register method we saw earlier. We're passing in these values that are base64 encoded. We're converting these values to uint8 array values. And then down here, we call this navigator.credentials.get method. This interacts with the FIDO device. If that interaction succeeds, we'll get back a result. And we can then post that result back to the server. We're posting it back to the callback URL, which is this account FIDO complete login URL. If that succeeds, we then redirect to the return URL. And that return URL is the URL that Identity Server requires to complete its part of the authentication process. Okay, so what does this FIDO complete login endpoint look like? So again, it's an async method. This time it takes a base64 FIDO authentication response object. So the first thing I do in here is use the FIDO component to complete the authentication. And again, check to see that that was successful. So regardless of whether that complete authentication is successful, I want to sign out of the two-factor user ID scheme. So I'm finished with that scheme here. If this complete authentication was successful, we return OK, and that will cause the browser to redirect off to our redirect URL. So hopefully completing the identity server part of the authentication. If the complete authentication call fails, we return bad request. And in that case, the JavaScript code will just dump an error into the browser console for us. Now, if we are successful, we want to sign in using the default authentication scheme. So to do that, I need to get the claims from the currently signed in user. So I call authenticate async against the two-factor user ID scheme. I grab the claims from that principal, and then I extract the value of those claims. So you think back, we had a remember me claim, that's going to be Boolean. We have a username claim, and we have a subject ID claim. To log in, we create a set of authentication properties based on the value of the remember me claim. We call sign in async based on the subject ID and the username, and then these properties are based on the remember me claim. And again here, I'm assuming this is all going to work. So before I run this, I need to do one more thing. So here, I'm making use of this identity constants two-factor user ID scheme. But to use this, I have to add a cookie based on this. So if I go to the startup code for Identity Server, then down here where we call add authentication, I'm going to call add cookie. And into this, I'm going to add the two-factor user ID scheme cookie. And that corresponds on to the authentication we want to do with that cookie. Okay, so now that we have all of this in place, if I restart Identity Server and go back to my client application, so here now I click on privacy. It asks me to authenticate. I can register my device. Then if I log out, click on privacy again, then now it asks me to do two-factor authentication. So I have to use the FIDO device here. And now I'm logged in. If I go to my home page and then go back to privacy, I'm still authenticated. But now we've authenticated using our username and password and using the device. Okay, so we've just seen that if I restart Identity Server, I have to re-register the device. And that's because currently we're storing the device information in an in-memory store. Obviously in production, we like to store that information in a database. To do that, we have Entity Framework support on the component. So we'll see how we add that support now. And to do that, the first thing we'll do is to add a project to run the migrations for us to create the database. And then once we've had that, will integrate that database into the application. So to add migrations to this application, I'm going to do it in a separate project. Partly because it's cleaner and partly because you're going to run these migrations as a one-off and you don't necessarily want that code polluting the main application. So in here, I'll add a new project called migrations, and this will be an empty project. So I create this. Then if I open up this project startup.cs file, this is where we'll do all the work. So the first thing I want to do in here is add a constructor. Into that constructor, I'm going to pass an iConfiguration, and I'll assign this to a property, and we'll use this inside the configure services call. So since I configure services, then I'll add the code to do the migrations. And before I do this, I need to add some NuGet packages. I need 3 packages here. I need the RSK FIDO Entity Framework packages. I need the Microsoft Entity Framework Core SQLite package. And I need the Microsoft Entity Framework Core.design package. And we need this package to generate the migrations. Okay, so once I have those, back in the code, I need to do a couple of things. The first thing I need to do is to actually get the connection string that we'll use to generate the migrations. So to do that, I'll call configuration.getConnectionString, and I need to add this connection string to my app settings. So in the code, we ask for the connection string called DB, and we configure that here. I'm using SQLite, so this points at a file, and that file is up one directory in the IDS directory, and then it's called IdentityServer4.db. So that's this file here. Once I have that, I need to call add authentication. And this seems a little odd, but this registers a service that we need, one of the time services, and this is used by the component. I can then call services.addFIDO, and then on here we call add entity framework store. And add entity framework store takes an options, and on that options, we call use SQLite. And to this, we pass the connection string, and then this also takes an options, and then to this options, we pass the name of the assembly that contains the migrations, which is going to be S. We don't need any of the code inside the configure method, so I can get rid of all of that. And then I can build this code to make sure everything is okay. So I run these migrations from inside the terminal window. So I'm in the correct directory here. So to run this, we run .NET EF migrations add FIDO, which is the name of the migration, -C FIDO DB context, which is the name of the DB context, and we'll see how to get that in a moment. Then -O migrations-FIDO, and that's the output location for this migration. Now to run this command from the command prompt, you might need to install the Entity Framework tooling first. And you do that with .NET tool install -G for global .NET-EF. So if I run this, we've created the migration. I can then run .NET EF migration script with the same DB context and an output location of migrations FIDO.SQL. If I run this, this generates the SQL for me for these migrations. If we go and look at this, then in the project we'll see we have a migrations folder, and in here we have the code for the migrations and the SQL for the migration. When we apply these, it will apply these migrations to the database. So what about this DB context? Well, if I look at add entity framework store, inside here, we can see it calls add DB context, and the DB context it uses is the FIDO DB context. And that's the one we are using to build these migrations. Okay, once we have that, we can then apply the migrations to the database. So I do .NET EF database update, and again using FIDO DB context. And that updates the database for me. So back in the project, if I open the database window, go to IDS and find the identity server database, and drag that into the window and open up this schema. In here now, we have a FIDO keys table, and that's going to contain the keys for this application. So how do we use this? So for the IDS project, if I manage NuGet packages, I need to add the rock solid knowledge entity framework package into this project. In the app settings here, we already have a connection string, and this one's called default connection. So in startup for IDS, rather than calling add in memory store, I call add entity framework store. This takes an options, and we just want to say options.use SQLite here. And to this, we pass in a connection string. So again, I'll have a variable of CN for the connection string, and I'll grab that connection string from the configuration. Okay, so now that we have this, if I rerun the application, so I'll rerun Identity Server first, and then rerun the client, Okay, so in the client, I click on my privacy link. I sign in. I now need to register a device. So I'll call this UB. Click on submit. I use the device. I log out. And we know now that if I log back in, it asks for the device. And sure enough, I'm now authenticated. The difference now is this. If I go back to Rider and I restart Identity Server, if I log out, I'm now going to log back in. Now, previously at this point, I would not have a key registered because I was using an in-memory store. And every time I restarted Identity Server, that store went away. But now I'm using the Entity Framework store. So when I log in, it remembers the key. And I use the key and I'm now authenticated. If I go and look in this database, so I do a select star from FIDO keys, we can see the output here. And in here, we have a user ID of Alice and we have a key with a display name of UB. And that's the key I registered.